OSHA required written respiratory protection program, which includes but is not limited to initial and annual fit testing and user skill check and training. However, on March 14th, 2020, the Department of Labor issued temporary enforcement guidance permitting OSHA field offices to exercise enforcement discretion regarding the annual fit testing requirements until further notice. And following that initial guidance, on April 8th, the DOL further extended that guidance to apply to all businesses, not just to the healthcare setting, thereby relaxing fit testing requirements during the COVID-19 pandemic. Some employers, due to the shortage of N95s and the limited reuse capabilities of disinfected N95s, are moving toward NIOSH-approved elastomeric respirators, which provide an alternative respiratory protection option capable of decreasing the total number of respirators required, just because they may be cleaned, disinfected, and reused numerous times, which should reduce the number of respirators needed when supplies are limited. However, a supply of elastomeric respirator facepiece components should be held in reserve to replace any damaged or deteriorated parts, and supplies of replacement filters, cartridges, or canisters are also needed and should be taken into consideration when ordering or using reusable elastomeric facepiece respirators. These respirators are not cleared, or these filters rather, are not cleared by FDA for fluid resistance and require maintenance, including cleaning, disinfection, and inspection if they are to be used in a hospital setting. There are several types of filter media for use with NIOSH-approved reusable half-face-piece elastomeric respirators. All are sufficient at removing droplet and viral-sized particles when worn correctly for the duration of exposure. Filters are available for elastomeric respirators in 3 efficiency levels, similar to N95s, which include N99, N95, and N100, or P95, P99, P100, etc. During contingency and crisis capacity strategies, when shortages are predicted, but supplies are still available, elastomeric respirators should be used for the exclusive use of an individual employee, meaning each employee should be assigned their own individual elastomeric respirator. Elastomeric respirators must be cleaned as often as necessary to remain unsoiled and sanitary. As with N95 filtering facepiece respirators, achieving an adequate seal to the face is essential. OSHA regulations require a written respiratory protection program requiring workers to undergo an initial and annual fit test and to conduct user seal checks each time the respirator is donned or put on. Workers must pass an initial and annual fit test to confirm a proper seal before using a tight-fitting respirator in the workplace. Any exception to this program during the COVID pandemic, as allowed by the emergency guidance document, should be authorized and documented by the Respiratory Protection Program Administrator. Again, the emergency guidelines do indicate that employers still must use best practices and good faith efforts to comply with the respiratory protection standards and written program. For folks who use corrective lenses, conventionally, workers who wear a full facepiece respirator and need corrective lenses would have prescription inserts. In surge situations where multiple employees may share respirators, the use of prescription inserts might not be feasible. Employees who use glasses could wear half facepiece respirators instead of full facepiece respirators, with glasses worn over the respirator to avoid a situation where the arms of the glasses interfere with the respirator seal. The risk of contamination by solvent vapors does not apply in most healthcare settings, but it can in other traditional settings. Therefore, individuals who wear contact lenses should be able to wear either full face piece or half face piece respirators. However, the use of contact lenses in general could present additional risks where SARS coronavirus 2 exposures are known or suspected. Regarding cleaning and disinfecting of your elastomeric respirator, viruses and bacteria that cause acute respiratory infections can survive on respirator components for variable periods of time, from hours to weeks. Consequently, when used in a high-risk hospital setting, contaminated elastomeric respirators must be handled, cleaned, and disinfected properly to reduce the possibility of the device carrying infectious particles and contributing to disease transmission. Each respirator manufacturer identifies the appropriate cleaning products, which typically involve 1, using soap and warm water or chemical disinfectants authorized for use with their specific elastomeric face piece components, and 2, discarding the filter cartridge. For conventional use of elastomeric respirators, employees must consult with the manufacturer concerning the effectiveness and uncertainties of alternative cleaning and disinfectant solutions and procedures used for reuse of the face piece, strap, and filter components. The solution and procedures must be effective for disinfection, but must not damage the respirator, including causing damage to the filter media, which conventionally is discarded, and 2, should not cause harm such as skin irritation to the wearer. Prolonged or repeated use of disinfectants may damage or degrade respirator elastomeric components, including the face piece, valves, valve covers, and straps, causing components to discolor, swell, harden, and crack. So if our employees are noticing any of these components with their elastomeric respirators, they should bring them to the attention of their employer, and new respirators may be issued. You also have to keep in mind that strong solutions such as hypochlorite, which is commonly used in disinfecting for SARS, iodine, and high concentrations of alcohol may degrade, deteriorate, or extract chemical additives from certain respirator materials. So you have to be cautious when using disinfectant solutions on your respirator. Healthcare sterilization processes, including the ethylene oxide, should not be used unless it's authorized by the respirator manufacturer, as it could also degrade and alter the shape of the face piece. Steam sterilization equipment should not be used unless authorized by the respirator manufacturer. When donning or putting on your respirator, you should perform an inspection. All respirators used in routine situations should be inspected properly before each use and during cleaning. This includes a check of the respirator function, tightness of connections, and the condition of the various parts of the respirator, including the face piece, head straps, valves, cartridges, and canisters or filters. Inspect elastomeric parts for pliability and signs of deterioration. Respirators that fail an inspection or are otherwise found to be defective should be removed from service and discarded, repaired, or adjusted based on manufacturer recommendations. In all cases, discard filter cartridges if they become visibly soiled or wet, if they are visibly damaged, or if the respirator becomes notably harder to breathe through. Otherwise, change out filters periodically. Provided the cartridge integrity and filter have not been compromised, current practice shows that conservatively the filters could be used for at least 1 year. Regarding training, of course, workers must be educated and trained on how to safely use their elastomeric respirators. Employees should follow the respirator manufacturer's instructions and OSHA guidance to the greatest extent possible, and consider training recommendations that address all aspects of use, care, and cleaning of the respirator. To ensure respirator maintenance is conducted properly, employers should establish disinfection and cleaning procedures to train staff to perform the required maintenance, including storage, inspection, distribution, repair or replacement, cleaning, disinfection, and disposal. Employers may identify a central location for disinfection or train individual users to clean and disinfect their own respirators. Initial surface cleaning should be done at point of use before moving to a central location for disinfection. Regarding fit test requirements, for filtering face piece respirators, while fit testing requirements may be relaxed during the COVID-19 pandemic, if you are a new employee, if you are changing your respirator, if you've gotten new models and types of respirators, fit testing should be done, especially if workers are going to be using this elastomeric respirator in highly hazardous and dangerous situations. And all efforts to control or reduce the spread of the virus during this pandemic should be taken if and when a fit testing is required. There are two types of fit testing. For filtering face piece respirators, there's qualitative and quantitative fit testing methods. Both are effective at determining whether the respirator fits properly. This is defined in OSHA's respiratory protection standard, detailed in Title 29 of the Code of Federal Regulations 1910.134, Appendix A. Fit testing procedures. The fitted respirator can be safely used for work tasks that require respiratory protection. For additional guidance, please see the fact sheet on respiratory protection and fit testing on the teamstersafety.org website. Regarding seal checks, if respirator fit testing is not to be conducted, then employees should perform respirator seal checks. Positive pressure seal checks. If you are doing a positive pressure seal check, you would place your palm over the exhalation valve of your respirator and gently exhale. If the face piece balloons out slightly and you cannot feel leakage, you have a good seal check. If you're providing negative pressure seal, if you're going to conduct negative pressure seal checks, you want to block the ends of the cartridge with your hands. Gently inhale. If the face piece pulls in and you don't feel a leak, then chances are you have a good seal. Regarding disinfection considerations during the fit testing, during qualitative fit testing, usually saccharin or Bitrex is used. That's either sweet or very bitter product. A fit test subject will wear a hood during both the sensitivity test, which tests how sensitive you are to either the saccharin or the Bitrex, and the fit test. And so this hood would be placed over your respirator, and a nebulizer nozzle will be placed inside the hood during the fit test. And then you'll be introduced to either the saccharin or the Bitrex during the fit test. If you are wearing a respirator and can neither detect the saccharin or Bitrex, whatever is used, then you should have a good fit for that respirator. And of course, the hood that is used during that and the respirator, the nebulizer nozzles should all be cleaned and disinfected prior to next use or next fit test. During a quantitative fit test, an adapter tube must be inserted into the respirator past the inhalation valve and positioned near the mouth. This opens a path to the fit testing adapter and filter. The exterior of the tube and the interior of the fit test adapter should be disinfected between each fit test using a disinfectant from EPA's criteria list or one recommended by the manufacturer. Of course, fit testers actually have to have to practice good hygiene as well, because we don't want the fit tester to